Okay, so let's get going. I know not everyone's here yet, but let's jump in so long. Okay, so let's start introducing our different graphs. So, what were our three trig functions? What were the three trig functions that we learned when we did trig together? Good. Sine. That's our one. Cos. Good. And tan. I'm actually going to do these in different colors so that we can draw in different colors. So we've got sine, we have got cos, and we have got tan. Okay, can anyone tell me why I'm writing this as sine x, cos x, tan x, and not just sine, cos, and tan? Why do I need to have that x there? And what is that x? See if we can remember things from trig. Lee, what is that x?
Ma'am, isn't it perhaps because of the formula? The formula of the graph.
Of your graph. It does fall into that, but it's something else as well. I do see some answers coming through, which is great. Okay, x does represent a number, but there we go, we got the great answer. It's because it's an angle. Okay, the possible angle. Good. Okay, so this x, and this x, and sometimes they'll give it to you as a theta in like an equation work, but in functions it's always an x. No, but don't worry, it is part of your equation. So you were right, you weren't wrong. So that x is telling us that an angle is involved, okay, and your angle changes, and as your angle changes, then your numbers change. So just think about, if you grab your calculators for a second, and if you were to type into your calculator sine 30, for example, if you haven't got your calculators, go run and get them. If I was to type into my calculator sine 30, I'll see that my answer is 1/2. Okay, so sine of an angle gives me an answer. If I made it sine 60, then I get √3/2. So as my angle changes, then my answer changes. And that's the same way for any function. When we change our input, we change our output. Okay. So just as a very quick introduction to these three graphs that we're going to be spending the next few weeks on, our sine graph, I'm going to start from 0, is the main difference is that normally when we deal with functions on our x-axis, we deal with numbers. So we deal with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But those of you who have already done functions in class, what do we deal with on our x-axis when we're dealing with trig functions? What do we put on our x-axis? Come on, all of you munchkins that have done this already. Angles, yes, degrees, that's what we're going to do. So we're going to start at 0 degrees, then we're going to say 90 degrees, 180 degrees, and 270 degrees. And then, well, we should also have 360. So let's make these a little bit closer. So 180, 270, and then 360. Okay, so normally when we deal with our functions, we just work with numbers on the x-axis, but when we deal with trig functions, we work with angles, and we mainly work with these guys. So 90, 180, 270, and 360. Okay, and then we can get an idea of what our graph is going to look like. So I'm not going to go over this super slowly now because we're going to spend a lot of time on the sine graph. Okay. So it's going to look something like this. We're going to have a little wave, and that is going to be our sine function. So it's going to look something like that. Okay, that's in general what our sine graph looks like. So we have a maximum point. In this case, our maximum point is 1. We have a minimum point, which is -1. We have something called a period, which we're going to speak about in a little bit. And we're going to have an amplitude, which we're also going to talk about later. Okay. Now, the cos graph looks very similar to the sine graph. And don't worry, we're going to spend a lot of time talking about these sort of individually, so don't panic. I'm just going to make sure we have all our degrees. Your cos graph looks something like this. So we start up here, then we go down to our middle point, and we come back up, and we go to there. That's what our cos graph looks like. Exactly, period 360 degrees. Excellent. And then our tan graph is our sneaky graph, which has my favorite thing of all functions. What does the tan graph have that the sine and cos graph don't have? Tell me in the chat. Asymptotes. Yes, good. What are asymptotes? Tell me what an asymptote is. Okay, yes, the asymptote is the friend zone. It 100% is the friend zone. But what is it in mathematical terms? What is an asymptote?
The friend zone. Awesome.
Yes, there we go. It's a line that the graph doesn't touch. So it's a line that the graph gets really, really close to but doesn't touch. So for those of you who are new, we call asymptotes friend zones over here. So think about someone that you have in the friend zone. You get really, really close to them, but you're never ever going to kiss them. It's because you put them in the friend zone. So that's why the asymptote is our friend zone. Okay. So we have asymptotes in our tan graphs that happen every 180 degrees. Looks something like that. And then our tan graph is going to look something like this. Okay. And we have an asymptote there, and we'll have another asymptote there. So these are the three graphs that we're going to spend the next few weeks on. And today we're really just going to be focusing on this sine graph. Okay, so for those of you who have done this in class already, it'll be good revision and just get an idea of what everything looks like. And we'll see what we can play around with. Okay, but you are going to need your calculators today. So please make sure you have your calculators with you as we move into this. Okay. Well, we'll be doing tanics, so don't panic. So our sine graph is just our normal value. So if we're not going to do anything fancy to start with, we're just going to be y is equal to sine x. And just as we start introducing ourselves into this, when we start moving into more complicated versions of the sine graph, we're going to have y is equal to a sine bx plus q. Eventually, that's what our formula is going to look like, okay? In grade 10, we don't worry about that b too much, and so we just have a sine x plus q. Yeah, I can definitely go back for a second. Sorry, I should have said take a screenshot, and I didn't. It was my fault.
Screenshots time, guys.
Guys, the grade 9s are making me feel very self-conscious about my smiley faces, and now I'm nervous to draw them. You know my smiley face with the bow? They keep on telling me that it looks decapitated. And then I drew a smiley face that had a flower, and they said it looks like I drew a bomb on its head. Like so now I'm like very self-conscious about my smiley faces. But it's fine. Okay, so this is what we're going to progress to. And as we sort of start talking about this, I want you to kind of think about how this relates to what we did in functions already. What does the Q normally stand for when we're dealing with functions? What does the Q normally stand for? Think about an elevator. So sometimes it's the y-intercept, sometimes it's the asymptote, but for everything, the Q value does something. I'm looking for a specific word here. Thinking about an, there we go, it's the shift. It's the vertical shift. Okay, the Q is our shift. It's how the graph moves up or down. So think of the Q as your elevator. Okay, don't worry, Josh, if you're feeling lost, it will come down. Don't stress. This A stands for what in a sine trig graph? Okay, so we don't have a gradient. Good, it's the amplitude. Okay. Now, when we talk about A in functions, the A always told us our shape, and it does the same thing here. The A changes the shape. So it changes how tall my graph is going to be, and it changes if I'm going to go down before I go up. So it changes those types of things. It affects the shape of the graph. Okay. So let's have a look at just a very simple sine graph. So basically what I'm saying is we have y is equal to 1 sine x plus 0. So I'm not shifting anywhere and my amplitude is 1. What would that look like? Okay. And in order to get an idea of what that looks like, we're going to use this little table so that we can draw our graph. So in your calculator, for the first one, for example, over there, you're going to write sine and then in brackets, negative, don't forget your negative sign, negative 360, and tell me what that answer is. So write sine and then write negative 360 and tell me your answer. Nice. Good. Okay. I want you to fill out the rest of this. So tell me what our answer for sine negative 270 is. So I want you to be able to have all of those answers written. Nice. Keep going. And while you are doing that, I'm going to draw us a little set of axes quickly. Okay. What was my answer for negative 180? Yeah. Good. Negative 90. Negative 1. Good. Sine of 0. 0. Good. Sine of 1. Oh, I just gave you the answer. Sine of 90 is 1. Sine of 180. Now, the nice thing for these graphs is normally they give you something to draw on, which is very nice of them. Makes your life a little bit easier. Okay, but let's have a look at what this graph would look like. So then we're going to have 1, 0, we're going to have negative 1, and then we're going to have 0 again. Okay, so let's try and plot this graph. Remember, I'm going to make that 1 and I'm going to make this negative 1. So for those of you who are feeling a little bit confused that you're seeing degrees happening on the x-axis, when we're dealing with trig functions, on the x-axis, we always deal with degrees, and on the y-axis, we normally just deal with our numbers that we would have as our answer. Okay, so let's try and plot this. At negative 360, my y value is 0. At negative 270, my y value is 1. At negative 180, it's 0. At negative 90, it's negative 1. At 0, it's 0. At 90, it's 1. At 180, it's 0. At 270, it's negative 1. And at 360, it's 0. And then we have to try and draw this curve in. So we have curve in. Remember, it's not V's. We don't like V's. Make sure that this line goes on and have our little arrow. Curvy, curvy. Please all try to draw this on your side. You're going to need practice with drawing these dudes. They're quite nasty to draw. Chico Fatso, how can I help? I've unmuted you from the side, so you just need to click the button on your side. Okay, so all we've done at this point is we filled in our table by using our calculator. So we got these values by using our calculator, and then we plotted them as a point. Don't panic, Josh. So at negative 360, our y value was 0. So that would be that point over there. At negative 270, our y value was 1. So it's over there. Okay. So remember, when we draw these, you could write our coordinates as a negative 270 degrees and 1, because we're still drawing things on a graph. They're still coordinates, negative 180 degrees and 0. This would be negative 90 degrees and negative 1. This would be 0 and 0. This would be 90 degrees and 1. This would be 180 degrees and 0. 270 degrees and -1 and 360 degrees and 0. Okay, so we can always write coordinates for every point that we're writing over here. That's our x value and that's our y value. Okay, so we've got this graph. Now, some of the things that you can get asked here are, you can be asked about something called a period. Okay, and your period is how many degrees does it take for the curve to finish, so for a full curve to happen. So basically for the full curve to happen, how many degrees would that take? Okay, so if we have a look here, we have, if I start at 0, okay, so I'm starting down there and I'm going up and I come to here, that's 180 degrees. But the problem with that is then I'm not including this bottom section over here. So that's not its full curve. So that would be 180, and then to come back up, so for its full curve, that would be 360 degrees. Okay, so the period is how many degrees does it take for my full curve to happen. And in this case, it's 360 degrees. For those of you who are panicking about the pace, please don't stress. We're going to be doing tons of these during the lesson today. This is just the first graph that we're drawing. We're just looking at how to draw it and get some basic ideas of what's going on with it. Exactly. If you do physics, then this should be something that you've seen lots of. Okay, so that is our period. How long does it take for it to go through? The next thing is, if I wanted to know my maximum value and I wanted to know my minimum value, what is the maximum? So what is the maximum that this could be? Good. The maximum value can be as 1. Do you see it never goes higher than 1? Okay. What's the minimum value that this graph could be? Beautiful. -1. So the smallest that my graph can be is -1. And this max and this min, they tell us our range. So I know range is not everyone's favorite thing, but remember, range is looking at your possible y values. That's what a range is. So it's your possible y values. And our max and our min are telling us what our possible y values are. It's telling us that my graph only exists between 1 and -1. That is my range. And so if I was writing what my range is here, I would say that it's between -1 and 1. And I can use the closed brackets because I am allowed to be at -1 and I'm allowed to be at 1. Okay. So that would be my range. If you were writing it the other way, you would say y has to be less than or equal to 1, or greater than or equal to -1. Those are your two options. Okay. If I was wanting to find the domain, let's change color. If I was wanting to find the domain of this graph, that's looking at possible x values. What would the domain of this graph be? Yes, Tiama, exactly. This arrow is telling me that that graph is going to go on forever that way. This arrow is telling me that it's going to go on forever that way. I don't have any asymptotes, so I'm not stressed, which means I can say x is any real number. Okay, so we've got period, we have got domain, we've got range. And then the last thing we're going to look at is amplitude. And the amplitude is always going to be your A values. Now, when we have to start figuring it out, I'll show you. But there's lots of different ways that you can figure it out. But it's always just going to be your A, so your amplitude, different color. Don't panic. I know you're going to be seeing a whole bunch of new words and you're like, oh, what's going on? So your amplitude is your A value. The easiest way to find your A value, yes, so if a graph has asymptotes, then it will affect our domain and sometimes our range, depending on where the asymptotes are. The easiest way for you to find your amplitude is to take your maximum value and then minus your minimum value and divide it by 2. Okay, so your maximum value is 1, you're minusing -1, and you're dividing it by 2. So that's 1 plus 1 over 2, which is 2 over 2, which is 1. So my amplitude is 1. Okay. I personally like to just look for the middle part of the graph and look to my maximum point and see, well, that value is 1, and that's my amplitude. But you don't have to do that. You can always stick onto max minus min over 2. That will give you your amplitude. Okay. So now we've looked at period, we've looked at max, we've looked at min, we've looked at our domain and our range and our amplitude. And what you are looking at on your screen right now is a very, very basic sine graph. So this is as easy as your sine graph can come. I haven't shifted up or down, and I haven't changed my amplitude. So my amplitude is 1, and there's been no vertical shift at all. Okay. I'm just going to try and do this in stages for those of you who would like screenshots. I think that's the first page. So this is just looking at what graph we're drawing and what the equation of our sine graph is. So if you'd like to take a screenshot, there you can.
Take a screenshot. Oh, guys, it's so cold. I can see Kuma like with the blankets already to himself over there.
I know, it's very cold today. No, so for sine graph, when you do the positives, you can definitely be asked negative degrees, the way that we've been on all of these over here are negative degrees. So you can be asked to do it in negative degrees. Most of your schools, because it's the first year that you're learning, they'll only focus on this part over here. But you can be asked to do the negatives, but you just do it the same way in your calculator, so don't stress. Okay, cool. Oh, brain break. Okay, brain break of the day. Oh, hold on, let me go away from it for a second. For those of you who are new, this is just something silly to get your brain a little bit of a break from the hectic maths. Don't panic. It's not anything stressful. Okay. Okay, so brain break for today is you see a boat, it's filled with people. It has not sunk, but when you look again, so you look away from the boat and then you look to the boat, and when you look again at the boat, you don't see a single person on the boat. Why? Don't you dare Google the answer. Guys, how do you know this so quickly?
I don't
And eventually was there in like a second. Andre was there in a second.
Which books are you all reading? I didn't know this. Oh, great night.
When I found it, I was like, there's no way they'll get this. It'll be fine. No, they're not ghosts, guys. They are, they're the key word here was you don't see a single person on the boat, as in they are all married or in couples. Because you don't see a single person.
That's like the best answer.
I really appreciate the people over here though who don't. Oh, it's on TikTok. TikTok is ruining my brain breaks, Yolanda.
Oh, they got it on TikTok. I can't
Who do I take this up with? I need to talk to the manager of TikTok and be like, hey, these are my brain breaks and you're not allowed to use them. No one can post about them. Okay. Well, there we go. That was your brain break of the day. They definitely did not all jump, but they are not all ghosts. They are just married or in couples. Okay. Okay. We are now going to have a look at what this graph can look like when we start changing things a little bit. So if I have a look at this table, I've made it a little bit easier. So we're just dealing with 0 to 360. Okay. The thing that I've changed is our amplitude. So we've got a half over there, we've got a 2 over here, and then we've got a different color, -3 over here. And I want to see how this changes. So the way that your graph changes, the way that it lands up looking. Okay, so I'm going to put in the values for our normal sine graph because you've already done that. You did those values yourselves just now. And I would like you to start thinking about what our other values are going to look like. So here we've got 0, 1, 0, -1, 0. That's what that first graph would look like. I'm going to draw that for you so long while you work on the rest here. Okay, so we've got 0 and 0. 90 and 1, 180 and 0, 270 and -1, and 360 and 0. Oh. Okay. So that is my regular sine graph with no shifts and an amplitude of 1. Okay, so no shifts and an amplitude of 1. That's what you're looking at in this first graph. So this is y equals sine x. And now I'll start thinking about what my next graph is going to look like. So now I'll start looking at this guy. If you're feeling lost and you don't know how to do that on your calculator, you're just going to say, you're going to write a half. So push your fraction key and write a half, and then say times sine, and then in brackets, you would have 0 degrees. So you're going to have 0, and you should get an answer of 0. Maybe some of you will start seeing a pattern here, which will be helpful. It will make your life a little bit easier. But I'm seeing some good answers coming in the chat. Half, 0. Nice. -1/2. Good. Okay. Well, I'm going to plot that. So we have 0, then we have a half, we have 0, we have -1/2, and we have 0. So, little flat graph. Just draw that in, and that's y is equal to a half sine x. Okay, so before we jump into y is equal to 2 sine x, we've got these two graphs here. What can you see has happened when we changed our amplitude from 1 to a half? What happened to our graph? So what's the difference here between the pink one and the blue one? What happened between the pink graph and the blue graph? So it hasn't shifted. So that's the careful thing. So it hasn't shifted. And the reason we know it hasn't shifted is because I have no Q value. All of these would be +0. And the Q is what tells us it shifts. So becoming wider, we need to be careful with that words, because wider is meaning the period has changed. And the period is still 360 degrees. It's still, the full curve is 360. Yes, all the way to excellent. The range is different, okay, because our amplitude is different. Great. Good. Zama, how can I help?
I can see the difference between the blue graph and the pink graph. The pink one turns at at 1 and -1. The blue one turns at 0.5, I think.
Yeah, that's right.
And -0.5.
Good.
Yes.
Okay. Excellent. So basically what's happened is we've changed our max and our min, right? So our maximum value and our minimum value are now lower. So we've changed the range. So our amplitude changes our amplitude and changes the range. Okay. If we sort of try and follow in the rest of this pattern, if we're now looking, we have y is equal to 2 sine x. That's still going to be 0. Okay. What do you think this value is going to be here without using your calculator? I want you to try and see if you can think of a pattern. What would that number be if our graph was y is equal to 2 sine x? Yes, Emmanuel, beautiful. It would be 2, okay? Because that's telling us where that amplitude is changing. Then we're going to have 0, we're going to have -2, and we're going to have 0. Because what we're drawing is as that number changes, it changes our maximum and our minimum values of our y. So it either makes our graph taller or shorter, changes its height. Okay, so this would be y is equal to 2 sine x. So now my maximum is 2 and my minimum is -2. And so now my amplitude would be 2, but my range is now going to be from 2 to -2. And yeah, it's all going to be easy. Yeah, don't worry about using a calculator. Sometimes we can just do it in our heads because we're brain buffs. Now, the next one's a little bit sneakier because there's a negative. So I do recommend, we know that that's going to be 0, but I do recommend you use your calculator for the first value over here because it's going to look a little bit different. So now we're going to write -3 times sine, and then in brackets, we're going to write 90 degrees. And we're going to close that bracket. Oh no, Alex, where are you getting lost, sweetheart? Just let us know. Yolanda will fly to the rescue, I promise. Good. Negative.
I will. I'm here, Alex.
And then we're going to have 0 again. And then I want you to tell me what we're going to have for 270. And we know that's going to be 0. Good. It's going to be 3. Nice. Okay. So now if I'm plotting that, I'm going to have 0. I'm going to have -3. I'm going to have 0. I'm going to have +3. And then I'm going to have 0 again. So now my graph is looking like this. Okay. So do you remember when we were dealing with parabolas, when A was positive or A was negative, it changed the way that the parabola looked. So if A was positive, then we had a happy parabola, and if A was negative, then we had a sad parabola. This kind of does something similar. So when A is positive, like it is for our blue, pink, and purple graph, then we first start by going up. So we go up first. And when A is negative, like it is in our yellow graph, we go down first. So the reason the yellow graph is different is because our A value is negative. And because our A value is negative, our graph is going to go down before going up. And if it was purple, pink, and blue, it's going to go up before going down. But that, if you sort of work with your calculator, you'll always be able to do that. I just wanted you to be able to see this sort of as a visual. Lisa, how can I help? Okay. While Lisa's getting, oh, there we go. Hello, Lisa.
See that the yellow graph is 2 different. Why?
Okay,
I'm getting
so,
lost right now, ma'am.
No, it's okay. Don't panic. So the yellow graph is different because it's well, it's bigger, it's taller because of that 3. So that 3 means it's going to be much bigger. Our amplitude is going to be 3. And because it's a negative, instead of starting and going up first, so that's what it would look like if it was 3 sine x. Instead of going up first, we're going to go down first because it's a negative. That's the only thing that's different here. So we're just starting by having a negative sine graph. That's all that's going on. Yeah, guys, if you're having Wi-Fi issues, please don't panic. Why do you have to add the +0? You don't have to add the +0. The +0 is just there to show you that there's no shift. We haven't shifted up or down. Okay, so let's have a look at this. Our purple graph over here, that's the purple graph. Okay, our max is 2, our min is 2, which means our range, which is your possible y values, would be between -2 and 2. That's what our range would be, okay? And our amplitude, remember that's your max minus your min divided by 2. So that's 2 minus -2 over 2, which is going to give us 4 over 2, which is 2, which is the same as that number over there. Okay, let's look at our blue graph. Blue graph, our range of our blue graph, we're going from -0.5 to +0.5. And our amplitude is going to be 1/2. Okay, so our max minus our min over 2, and you can do that all in your calculator. Let's have a look at our sine graph, just this pink one over here. Our range, we've just spoken about it. It's between -1 and 1, and our amplitude is going to be 1. So as our amplitude changes, our range changes, but our graph isn't moving up or down at all. It's just changing how tall the graph is. And in this case, our range is between -3 and 3, and our amplitude is still 3. Okay, that's just looking at what these would look like when we start changing our amplitudes around. Okay.
Hey, screenshot time.
Yeah, if you want to take a screenshot, this is your moment. I also want to show you how you can do this on your calculator.
We really appreciate this line, Teacher Jenny. Oh, they're perfect.
They're great. Eh?
I know how hard it is to get the lines like this.
Oh, I struggle. Why did I start with the negative and then the positive? So for y equals negative 3x, 3 sine x, that if I put in 90 degrees for negative 3 times sine x, I'm going to get negative 3. So I'm not choosing what that is. I'm putting it into the equation of y equals negative 3 sine x. And that's how I get the answer of negative 3. So it's not a choice. I'm putting it in. Oh, for the range, we always put the lowest value it can be and then the highest value. So we always write the smallest and then the biggest every time. Lisa, hi.
So my teacher earlier said when your graph starts at negatives then ends at positives. So your range will be, or your y-axis will be negative infinity is to positive infinity. So here we are using numbers.
No, so it's your range for a sine graph and for a cos graph will never be from negative infinity to positive infinity, but it would be that for a tan graph, but not for sine and cos.
Okay, sure.
Okay. Okay, amplitude will come with time. Don't panic about your amplitude just yet. I know I'm throwing a whole bunch of new words at you in this new section, so don't panic. And also remember, guys, you need to try and just always remember in our first lesson of every new course, it's always a little bit overwhelming and scary. That's normal, okay? So you're feeling normal feelings. It's okay. But we will go over amplitude. We're going to be doing it a lot as we move through these. Asmati, how can I help?
Ma'am, can you please explain about the range? I'm a bit lost.
Okay, so our range, when we're looking at our range, basically what we're doing is we're saying what is our minimum value and what is our maximum value. And that's always going to be our minimum and that's going to be our maximum. So if you have a look at, let's look at the blue one, our minimum is -0.5 and our maximum is 0.5. So our range, we're just going to write what our minimum value is and what our maximum value is. That's what gives us our range. Sandra, how can I help? I can't hear you. I think you're going to need to speak closer to your mic.
Sandra, I'll assist you with the audio because we cannot hear you. So we'll just have a chat just now.
Guys, there's also a sneaky way that you can do this on your calculator, which we can chat about. I don't want to confuse everyone too much, but I do think it is worth having a look at it. But maybe let's do that in our lesson on Thursday so that I'm not trying to stuff too much information in your brain tonight. Let's maybe keep that for a Thursday thing. Okay, so I'm gonna take this away. We're gonna deal with this little suggestion on Thursday because I'm scared I'm putting too much information into your brains this evening. But we'll come back to it, I promise. So for the amplitude, you always take your maximum minus your minimum and divide by 2. And your period is always just looking at how long it takes for the curve to complete itself. And as long as we're dealing with grade 10, for sine and cos, your period is going to be 360. We're not going to change that just yet. We change it in grade 11, but we don't change it in grade 10. Okay. So what we're gonna do, I promise I will show you how to do it on the calculator. For those of you who are having exams or things happening this week, I'll show you at the end of the lesson once our time's finished, okay? I just don't want to confuse people who are seeing this for the first time today. When we're having a look at these graphs now, what have I changed? I want you to think of exactly tan period is 180. I want you to think of this as our equation. So y is equal to a sine x plus q. So in our last graphs, we were affecting a. So we were affecting our amplitude, which means we were affecting how tall our graph was going to be. What are we changing now? Beautiful. I'm changing q. I'm changing q. Okay. And by changing q, it means I'm shifting. So I'm moving my graph up and I'm moving my graph down. So I want to show you what this would look like. If I was to write y is equal to sine x, we know those values now. We've dealt with them a lot. Okay, so we have 0, 1, 0, negative 1, 0. That's our normal sine graph. Okay, so let's just plot that quickly. We have 0, 1, 0, negative 1, 0. This is our sine graph. And please draw these on your side, guys. They take practice to get right. All right, that's our normal sine graph. That is equal to y equals sine x. I'm going to show you how we can do this with things. So for your turning points and x-intercepts, it depends on how the question is asking you to label. If you were wanting to write your turning points, you would say 90 and 1. We are going to get into all of that into a little bit more detail when we actually sort of understand the graph a little bit more. For the moment, we're just trying to figure out how we would draw this. Okay, but generally, general rule of thumb is always give your turning points, always give your intercepts. Okay. We're now going to imagine for the second graph over here, we've got y is equal to sine x plus 1. And we know that we're changing q. And we know that q is a shift. It's a vertical shift as we go up or as we go down. Okay. So thinking about this graph over here, we've got this sine graph just chilling. So that's the one we've done. We've done this graph now 3 times. This is the same graph that we're drawing. If I was to shift this whole graph up by 1, is that going to change things? Is it going to make my graph look different? Is it going to change my max and min? Is it going to change my amplitude? I want you to tell me what you think. What do you think is going to happen if I have to shift this whole graph up by 1? Okay, so it won't start at 2 and it won't change the amplitude. It could change the range, good. And we are moving up once. The graph will start at 1, great, great. There will be no negative numbers, perfect, good. Okay, so for those of you who are like, how are they seeing this? Let's try and imagine. All of the points that we are currently at, we are going to shift them up by 1. So this was at 0, and now we're shifting it to 1. This was at 1, and so we're shifting it to 2. This was at 0, so we're shifting to 1. This was at negative 1, so we're shifting to 0. And this was at 0, so we're shifting to 1. So when we draw this graph, what we should see is that it is the exact same graph as our yellow graph. It should look exactly the same. So our graph should look exactly the same. The only thing that has happened is that I have moved it up by 1. But the graph itself is exactly the same. So our period is the same. Our amplitude is still 1, remember, because that's our A value. In all of these, we have an amplitude of 1. So our amplitude stays the same. We're just moving that graph up by 1. So if I was to write these points, I would have 1, 2, 1, 0, 1. And again, you can do this on your calculator. So on your calculator, you would say sine, and then in brackets, 0 for 0 degrees, and then plus 1 equals, and you'll get 1. Okay, so you can always do this for your calculator. Okay, now if we're having a look at this, so now we're looking at y is equal to sine x plus 1. What is my range of y equals sine x plus 1? What is my range? What is my minimum value? What is my maximum value? What is my range? Okay, so your amplitude is 1, Portia. So amplitude is definitely 1. What would be my range though? Remember, range is your minimum value and your maximum value. 0 and 2. Glorious. My minimum value is 0 because that's 270 and 0. My maximum value is 1. That's 90 and 2. Okay. So we're just looking at the change of our range, but our amplitude is still 1 because that A value at the beginning of our graph is still 1. Okay, so keeping that in mind, if we were now looking at this guy over here, without using our calculators, without using our calculators. What do you think these numbers would be? So we've got 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. I'm now going to be at 2. What's going to be my next number? 3. Yes. Oh, I fell for the trap of saying 4. It's going to go back to 2. Then it's going to be 1. Yes. And then it's going to go back to 2. Okay, so we're going to have 2. We're going to go up to 3. We're going to go back to 2. We're going to go down to 1. We're going to go back to 2. And so we get again the exact same graph. The shape should be exactly the same. But from this graph to that graph, I have added 2. I have shifted up 2. That's what that plus Q value is telling us. We're shifting up 2. That's all it's doing. Okay. And this last one over here is saying we're not shifting up 2, we are shifting down 1. Okay, guys, the conversation about WhatsApp in the chat, that's not the place for the chat. We need to keep things mathematical so that Yolanda and I can actually see what you guys are asking so we can know maths questions. Okay. All right, 0 degrees, 90 degrees, 180, 270, 360. If we're shifting this graph down, we're going to start at -1. So now instead of at 0, we're going to start here. Instead of at 1, we're going to start at 0. Instead of at 0, we're going to go to -1. Instead of -1, we're going to be at -2. And again, we have this exact same graph. It's just being shifted down by 1. Okay. Don't worry, I'll come back to the screen. But the important thing to see is that in what we did here is we changed our A value. Okay, so y is equal to A sine x plus q. In these graphs, we were affecting our A value, so we were affecting our amplitude, which is why some of them are really tall and some of them are really flat. So that's our amplitude. And in this one, we didn't change our amplitude. Our amplitude stayed as 1 for all of them. The only thing we changed was our Q value, which means we were shifting our graph up or shifting our graph down. That's what happened when we changed our Q value. Okay. Okay. I'm hoping that some of this is starting to feel a little bit less scary. For those of you who saw this for the first time, can you let me know if it's a little bit less scary than when you started? You don't have to be loving it or feel like you know exactly what's going on. I will completely be happy with slightly less scary than what you started with. Juliet, exactly. They are beautiful.
They are really beautiful. I agree, guys.
Good, guys. I'm glad that you're enjoying this. I promise it's not scary when we start going through it. The reason it looks scary is because it's so different to what you've drawn before, which I understand, but it comes. Oh, naughty, no. I'm sending you Linda your way.
I got you, Unati. I got you.
Lorato, how can I help? Oh, I can't hear you. Can you try to go a bit closer to your mic? Okay. If you start talking, I will talk to you. Yes, Canva, unfortunately, it does get a little bit more complicated than this. But, no, so Kevin, this is just learning how to draw them. It does get a bit more complicated, but not too much more complicated, I promise. Okay, so now let's have a look at these. Oh, don't worry, Lorato. So now let's have a look at these graphs. Now what's happening? Miss Cindy, can I help? What we're going to do here is now we're going to change our A's and we're going to change our Q's. So sometimes it is helpful for these to actually just draw it out on your table. So I'm just, for your first one over here, this is going to be 0, 1, 0, -1, 0. But if you were wanting to do the next graph, for example, in your calculator, you would write negative sine. And then we want 0 degrees. So close, don't forget to close that bracket for 0 degrees plus 1. Hopefully you can see what I'm holding in the camera right now. That's exactly what that should look like. So negative sine in brackets 0 plus 1, and you push equals, and you will see that your answer is 1. And try and work through what 90, 180, 270, and 360 is. I'm just going to quickly zoom up for those who want to do screenshots. You can quickly take a screenshot here. And then I'm going to go back down. Oh, Georgia, I feel like a light bulb has just gone off, which is great. I love light bulb moments. And then don't clear your calculator when you're at this point over here, then you're wasting your time. You just take your little arrow and you move your arrow till you go to where the 0 is in your bracket. Okay, and we just push delete because we don't want 0 anymore, and now we want 90. And you fill in the 90. Makes your life much easier. And push equals. And you'll see it's 0. And again, don't cancel what you have in your calculator. Just take your arrow and move back to where you have 90. And instead of 90, we want 180. And just keep changing until we get to where we want to be. So 270 is going to give us 2. And then we want 360, which is going to give us 1. Okay. So if we were wanting to plot that at 0 degrees, okay, at 0 degrees, our y value is 1. So that's 0 and 1. Next one, at 90 degrees, our y value is 0. So at 90 degrees, our y value is 0. At 180 degrees, our y value is 1. At 270 degrees, our y value is 2. And at 360 degrees, our y value is 1. Okay. And so we just draw that in. Oh, gosh, that's going the wrong way. Minimum. And then we slowly come up to our maximum. And we bring it down. And that would be y is equal to negative sine x plus 1. So we actually don't need to know anything fancy because we always have our calculator. We can always put these in and to get those values. So the values that we're wanting to do when we're wanting to work out any sine or cos graph is 0, 90, 180, 270, and 360, but it depends on what type of graph they've given you. So when it comes to writing coordinates, we always want to write our intercepts. So you're going to want to write that one, you're going to want to write that one, and then normally we like writing your max and min. So you're going to want to write that one as well. So those 3 would be sort of the compulsory ones to write. Okay. I'd love for everyone, I know that our time is like drastically running out, but I'd love for everyone to give this one a try. So the y is equal to 2 sine x minus 1. I'd like you to try and figure out what those coordinates are. I'd like you to try and draw it. Give it a go. And then I'll draw it on the screen just before our time has run out. Yes. Do you know that before the calculator, some of your parents may have even had to do this. I know that my mom had to learn trig this way. They had a book that was like a book filled with trig ratios. And you would have to look in the book and look in the columns and be like, what is sine 30? And look in the book and see what that would equal. And then what is sine 60? What is that equal to?
That's true.
That's like legitimately how they did maths. So you're all very lucky. I used to moan about this when I was in school, and then my mom would say, well, in my day. Ah, there you go, Comfy, your mom learned trig. Oh, Lottie, they make you do that now. That's so nasty. Yes, you should. In Kateko, that's great. You should respect them more, knowing that this is how they had to learn trig. Remember, they went through maths with no calculators. So whenever you feel like being sassy to your parents, you just think, they did maths without a calculator, and you just bring that sass level right down. They did trig without calculators and assignments without the internet. So you give them all the respect. Okay, so let's have a look at what this would look like. So if I was to put into my calculator 2 sine x minus 1, I'm going to say 2 sine, and then my x value is 0, and I'm now saying minus 1. Okay, and so that's going to give me -1. Nice job, guys. Then I'm going to have 1. I'm loving the answers that are coming in. They're great. Then I'm going to have -1 and -3 and -1. And then we just have to plot that. Okay, so at 0 degrees, we're at -1. I know pretty our time, just like, I don't know where our time goes. So at 0 degrees, it's -1. Then at 90 degrees, it's 1. At 90 degrees, it's 1. At 180 degrees, it's, oh goodness, it's -1. At 270 degrees, it's -3, all the way down here. And then at 360, it's -1. So we're going to go up. Oh, that's a terrible curve. We're going to up. We're going to curve at 90 degrees. We're going to go all the way down to our minimum down here. And then we're going to go right back up to that -1. And this is going to be y is equal to 2 sine x minus 1. Okay. So my maximum is 1. My minimum is down here, which is 270 degrees and -3. So my question to you is, in this blue graph, what would be my range? What would be my range? What would be those two values? What's my range of this blue graph? Look at your minimum value and look at your maximum value. Beautiful. -3 is my minimum and 1 is my maximum. That's my range. Okay. Now look at the graph itself. So y equals 2 sine x minus 1. Just looking at that equation, what is my amplitude? In the graph, y equals 2 sine x minus 1. What is my amplitude? What is my A? Yes, your amplitude is 2. Your amplitude is always going to be that number. Okay, it's going to be that A value. So your amplitude is 2. Beautiful. Great. Excellent, guys. You've done good work today. This was a good introduction to the sine graph. We're going to start on Thursday. We're going to learn how to find the equation of the sine graph, and we're going to answer some more questions about it. So it's going to be quite cool. But this was just to sort of start learning about exactly period is 360. This is just to sort of get an introduction into it. So all of you lovely lambs who are finished, this was the first time seeing trig, please don't panic. You're welcome to go. Those of you who still want to learn how to do it on your calculator, just stay around with me for a little bit, okay? So I can show you.
Don't forget the pace, guys. Do the pace. Thank you.
Nati, I'm glad you like this. That's great. Bye, guys. Bye, everyone. Those who are not staying for the calculator parts, have a great time. I'll see you on Thursday. If you have an exam before then, good luck. Emmanuel, how can I help?
Hello, ma'am.
Hi.
Ma'am, I wanted to ask, ma'am, I'm so sorry to ask this, but how do you figure out the amplitude, ma'am? I feel like I forgot it.
No, it's okay. So your amplitude is always going to be your maximum value minus your minimum value divided by 2. So here my maximum value is 1. My minimum value is -3, and I'm going to put that over 2. So that's 1 plus 3, which is 4, 4 over 2, which is 2.
Oh, okay. Thank you, ma'am. I forgot to put the brackets. That's why.
Okay. Okay. Yeah, that's normal. Zandasile, how can I help?
Hello, ma'am.
Hi.
Ma'am, is the period always 360 degrees?
For sine and cos, yes. Until we start bringing b into the equation, the period will stay 360.
Okay, thank you.
Sure. Okay. Okay, those of you who want to know how to do this on the calculator, basically we use a function called the table function. So if you go, I'm gonna just write it on the side over here. You're going to want to click on mode on your calculator. Okay, so you're going to click on mode, so it should say mode or setup, and we're wanting to be in the table function. So on my calculator, the table function is 7, but your calculator may have it at a different function. So you want to choose whichever option says table, whatever option says table. So for me, that option is 7. Depends on what your calculators are. So I'm going to push 7. And then what you should have on your calculators, it should look like this. F of x in brackets is equal to something. Okay. Now remember, when we started working with f of x, when we were dealing with functions, that f of x meant that it's like dealing with the y. Okay. So we are now just going to put in the equation that we want. So let's say we were dealing with this blue graph. We are now going to write what we care about. So you're literally going to write 2 sine. So 2 sine. And now we need an x, right? Because in our equation, we have an x and we need to find an x on the calculator. And if you have a look, you'll see that above your bracket, you've got a little pink x that's chilling over there. Okay. In order to get that pink x, we need to push alpha. So now we're going to push alpha. And then we're going to push the bracket, which has the x, which has the little pink x above it, okay? And then you'll be able to have the x over there. You're going to close that bracket. So it's going to look like this. And then you're going to write -1. And so at the moment, that whole equation should be in your calculator. Okay. All right. Then we're going to push equals. And now it should come up as an option of having g of x. We don't have a second graph. We don't have a g of x, so we can ignore that. So we're just going to push equals. Start, when it says start with a question mark, that's saying what is our beginning x value. So in this case, our beginning x value is 0. Okay, so our starting x value is 0. So you're going to want to write 0. And our end x value is 360. So we're going to write 360. And we're going to push equals. Exactly, Zama. We're stepping, which means every time when it says step, it's saying how often are we wanting to plot a point, right? And we plotted every 90 degrees. So our step is 90. That's saying how often do we want to plot? So we want to plot every 90 degrees. You can push equals. And then what you should see is you have this beautiful table, which is basically what we have in front of us. So it's saying when x is 0, then y is -1. When x is 90, y is 1. When x is 180, y is -1. When x is 270, y is -3. And you just use your down arrow as you move through the table. And it will give you all the same values as we have written in our table in blue. So it just makes your life a little bit quicker. That's all.
It does. It makes life a little bit easier.
And it kind of feels like you're cheating, which I always like. I always like to feel like I'm cheating when I'm not really cheating.
Jan.
I do. It makes me feel naughty. But you can always, so if you follow these steps, you'll always be fine. Okay. And I will go through this again with everyone on Thursday. So don't stress you. It's not the last time you'll see it. No, Tariq, you should tell everyone about it. Help out your mates.
It's information to help out a friend, okay?
No. Sharing is caring. Okay. If you haven't filled out the lesson, please can you do that? Otherwise, I hope you have a great evening and we will see you guys on Thursday.